of Amazon. You know, like, yeah, and eBay and stuff like that. Marketing is way easier. For 25 years of my life, I worked for myself. That's what money was always the big problem. That's why I lost my company. I also noticed your site. Way easier. Also,
all right. Testing, testing. 1, 2, 3. All right. We've got about a minute and a half until we're going to fire up the meeting here.
Yeah, it's all going to be cloud-based services. So, you don't need a payroll for 40 hours.
Dennis, stream's good, audio's good.
If you're not entrepreneur and you're spending a day, we don't have payrolls anymore. You don't have enough. You can't hire.
They must have all popped.
So, we've got one out to it as a service on the cloud or something, And there's no way to pull in any. Yep. I want to see how to do it. Right, contractor looking out. That will be fine to see how hard. Yes. That'll be interesting.
If we had a YouTube video, could you show it into the stream?
Working on it.
So that's another thing that we don't know how to do?
I'm suddenly incented to understand the lay of the land. I'm learning about RTMP and all sorts of
15 seconds. If you're talking now, maybe you should consider stop talking and sitting down. Andreas, if you're listening now, you should stop listening and sit down. Ting! Accuracy, precision, what does it all mean? Welcome, and I'm Kevin Appert. I'm the program chairman of the Silicon Valley Fourth Interest Group. Welcome to the afternoon session for July. I keep wanting to say August. I'm ahead of myself. And I'd like to invoke a round of applause for our longstanding webcaster for overcoming another round of Google, we don't like to actually provide something that works. It's too easy. So the fact that this apparently it was streaming 2 minutes ago when I checked it, but I could barely walk and chew gum at the same time. I can't blather and monitor the stream at the same time. So who knows if it's working. I'm sure it's fine. So thank you, Dennis. And all of you out on the interwebs, well, we can't hear you clap, but we're hoping you're going to do so anyway. So the first item on the agenda is rumors, gossip, introductions, announcements. Let's go around the room first. Nobody can do a project that Dennis worked on because Dennis is here. I would talk about the Canadarm simulator or the expert system for diagnosing automotive problems in the pre CAN bus. What's the automotive diagnostic connector called? OBD2, because OBD1, I don't know. Anyway, so I'm Kevin Appert, and a project that I'd like to say a few words about is the LiDAR project. You can go to the Fourth Incorporated website and see some of the things that I worked on There's a telemetry antenna there that Forth Incorporated had a piece of that I worked on back when I was at Big Deal Aerospace many years ago. Anyway, the LiDAR had a little computer that would control its laser diodes. There were like 4 slave diodes and 1 master honkin' big pump diode, and they all had PID loops running to run their coolers, and another thing that would control the on-off and intensity of the actual laser. And also, it was hooked up to a laptop that had another Forth program on it running a console. So the user interface was just a bunch of numbers on the screen, and you'd move the cursor around to the one you wanted to change. And it was all less painful to to implement in Forth than it was to understand all the hardware and the software and the details of getting the job done. So the thing about Forth in this case was that it made the actual task of getting this thing to work after it was understood and working. It was seamless and transparent in Forth, whereas if I had had to do it in some other thing, it would have been truly painful. So we're going to go around the room and everybody's going to say, you know, hopefully a less verbose blathering about a particular Forth project that they know about. It doesn't have to be one you worked on. Sam?
So I'm Sam Felvo. I'm the person behind the Kestrel computer project. And I use Forth in the Kestrel in more or less equal parts for software development on the development side, or I'm sorry, the host side, as well as on the target side. So the system firmware of the Kestrel also runs Forth. So that's where I'm at.
I'm George. While working on a personal project, not strictly Forth, I picked up the current issue of Scientific American and found a letter from the editor, not addressed personally to me, but saying, here's another issue with the perils of being a woman who speaks up in a bureaucracy. From the perspective of a woman who maybe hasn't had enough experience being a man speaking up in a bureaucracy. Also, what to do about guns? Scientific American, because this is a science thing. It reminded me the difference between unconstitutional and anti-constitutional. Save something for next month. But briefly, that incompleteness theorem, where you cannot have a formal system which is both complete and consistent, that there will always be a subversion. I cannot be played on your record. You think you can play every record? I cannot be played on your record player. And shall we just say that those who would upset and subvert our ways win because they have found a solution to our ways? Or do we think outside the box? Our hobby is thinking outside the box, so let us continue.
Don Golding, had a robotics company in the 90s, sold a couple thousand robots, and we're working on a brand new controller, which I'll give a talk later on today.
You're up, Dave.
Hi, I'm Dave Jaffe. One Forth activity I was involved in early on here at Stanford was introducing Forth in a mechatronics class here. We used some STD bus computers, 8085, and the students learned Forth. For some of them, it wasn't a very pleasant experience, but I think some other students got it. That went on for just a couple years before they graduated to versions of C, which they use now exclusively. Thank you.
I'm reminded of the XKCD cartoon where it is asserted that you can say that when you learn a new task, you can say you've programmed a neural net to perform it. So Dave wasn't programming computers so much as neural nets.
Yeah, carbon life form neural nets.
I'm Dennis Rufer, the videographer or whatever, which I'm handing off to Brad as of this meeting. My health is declining, so I may or may not be here much. We'll see how it goes. Most recently, I put FICL, which is a fourth inspired command language, onto an ESP32. Got that working, but don't know much about it. It's just, I didn't write FICL. But more recently, I got a ESP32 combined with a dual core RISC-V chip optimized for convoluted neural networks. And it's here now doing face recognition. Anybody can take a look at it.
So when you say face recognition, it recognizes something and says, that's a face? Or does it recognize something and says, that's Sam?
It does not do person recognition. It just does face recognition. This is a face. Yeah. But I'm figuring out how to do that now. It uses OpenMV machine vision, and you have to have OpenCV computer vision to make the models for the neural network, because it does not learn at this small of size.
Hello, I'm Andreas Wagner, and I worked on fourth HDL, an interactive fourth HDL word set for the PSOC 5LP chip, which has a ARM core, a CPLD, and a field programmable analog array on it. And I worked on a fourth interpreter for that, which compiles fourth to the CPLD, to digital logic, and spent a lot of time reverse engineering that. Now I'm doing other things, and I got some of the idea from the Testra project, which had this like fourth HDL, which is not available nowadays, not available anymore. I don't have the source code for it, but there were some articles in fourth dimensions about it, and that compiled to the CPLD. It was another fourth HDL. And I remember there's another fourth project that I liked, the Wiki Reader. Remember that? It was a offline Wikipedia browser device, and it was all written in fourth, and it also, you could write fourth programs on it as well, but I think you could even buy it at Walmart or something. I'm not sure, but it was all implemented in fourth. It was an offline Wikipedia browser with a fourth interpreter and other things on it. No longer available, but they're out there. Probably get one on eBay if you want.
So I'm Sean Chen. I used to do programming in CV for my robotics team, not anymore. And since the most complicated program I wrote in fourth is like printing stars, I was told to research a topic. And so I chose the HUT, which stands for Hopkins Ultraviolet Telescope. So it was like a 1,300 pound ultraviolet telescope that they put on the space shuttle. So it was used twice, once on the 1990 mission and once on the 1995 mission. And so it was coded in fourth, and it ran on two processors. One was called the SEP, the SEP, and one was called the DEP, the DEP. They were both identical, but one was used to process the input from the spectrograph, which is the thing that measures the input from the telescope. And the second was to move the actual telescope. But they were both like identical in like the hardware. And so it ran like about 10,000 operations a second. It was probably pretty good back then, but right now it's probably a really slow processor. So it ran at 25 megahertz, I think. So it'd be doubtful.
That was pretty fast in those days.
My name is Franklin Amador. I'm an electrical engineer, system integrator. I got involved in fourth because of the GA144, and then I've jumped to other things like the E4th from Tings. I've been buying his books and kind of emailing him about that to hopefully put an expert system on Don Golding's robot.
Okay, I'm the CH Ting, and I'm talking this morning about the all-cell computers are fourth computers, and God was or is a fourth programmer. But the problem, I think, is that you always find what you're looking for. So if I'm looking for fourth program in the genome, I will find it. Okay.
You wrote headless force.
Yeah.
Brad Nelson, various sundry whatnots with Forth, most notably probably Forth Haiku, a way to do graphical shaders in Forth. I will undoubtedly give some sort of talk at an upcoming FIG session on something or other, but I have not yet figured out what.
Well, thank you, gentlemen. That was very pleasant. I enjoyed that a lot. That brings to mind something that I'd like to talk about. I had a thought last couple of weeks about LaForth. Some of you will remember LaFar Stewart was here at SVFIG last month. But my question is, if I wanted to run a copy of LaForth, how would I find it? Where would I get? How would I get started? So if somebody wants to write an article or present a talk on that subject, I'd be grateful. And the same thing goes for Fickle. Is that the one that had the user license where it said if you were going to use it for government work or defense or military, anything, you couldn't? Is that am I thinking of the right? Was, what was the guy's name? Rody something? Oh, well. Maybe I'm thinking of some other dialect of Forth. It's not as if there aren't a lot of them.
I've seen that type of statement in my career.
Yeah.
But I can't remember where.
There was at least one version of Forth that I said, okay, well, fair's fair. And at the time, I was in that business, so I said, okay, they get to decide. But if you know where to get Fickle, Dennis, and how to get started with it, we'd be grateful if you'd tell us in some way. Uh-huh. SourceForge. Yeah, okay.
SourceForge.net.
Okay. I know where that is. Okay. So, I ran into a couple of things on we have a book here from written by this guy. He's the guy that rode his computerized bicycle across the country. So it's fun every once in a while to look at his website. Last post, I think, was last year. So he's still around, still doing stuff. I think he's plagued with the idea that there are more interesting things to do than post to his blog. It seems like there were a couple of interesting things on archive.org. The one that comes to mind right away is this. This is an archive of I believe it's a radio program, The Adventures of Sherlock Holmes. There's a pretty large number of them. So if you're just sitting around bored and want to listen to stuff, there's left-wing and right-wing podcasts, and there's stuff like this. Very interesting. They very recently had a number of good YouTube videos about the Apollo landing. So I recommend them to you. Bill Whittle did a very excellent, absolutely wonderful discussion. A lot less of the technology and more of the context, and talking about the culture and the society and the surroundings, the circumstances of the moon landing. And then there are these ne'er-do-wells that are restoring this Apollo guidance computer. And I don't know, is it up to 30 episodes yet? Some of which are longer than an hour, so you could spend a lot of time. But it did get a nice overview of the project on a less technical website that I posted to the list. No, nothing to do with fourth. We've wandered off into what we call not strictly fourth. This actual section of the meeting doesn't necessarily constrain itself to fourth, and sometimes there are presentations and discussions that have nothing to do with fourth whatsoever. So, what are we about now? The Vintage Computer Festival, eh? Coming up soon at the Computer History Museum. Dave? It's an ad. There was an actual ad on Google for the Vintage Computer Festival. What is this world coming to? So this coming weekend, 7 days hence, Dag Spicer is now on the board of the Vintage Computer Festival. And support from the Computer History Museum, does that mean that they get a discount for the rental of the room? So anyway, Dag Spicer is giving like the keynote or the welcome speech. 1401 demonstration is something you can see at the Computer History Museum any old time. The DEC PDP-1 demonstration, Apple I Owners panel discussion, and so on. So Apple I live demonstration, wow. I guess there's going to be a at least a couple of old Apple I boards there. I heard a rumor that there's going to be an auction of a non-working Apollo guidance computer, and interestingly enough, somebody is going to talk. There's no speaker attributed to this, but the Apollo guidance computer lecture is going to be on Sunday at 1. I wouldn't miss that for the world. Cadet writer. And then it's over. And there's usually lots of fun stuff. You'll be, bring your own dolly or your own hand truck and gloves. It's always interesting when I see people show up to move something and they don't have any dollies or hand trucks or straps or moving pads or gloves or anything. All right. Or something. I don't know. But I asked Eric to come and blather at us, but he's busy organizing the Vintage Computer Festival because it's just 1 week and he's got a million things to do. So next time we'll get him to record a YouTube video, and we'll show it a month before, a few days before the actual event.
If you can't make it, take photos of presentation at our August meeting. Vintage Computer Festival photos at the August SVFIG meeting.
Well, that'll be so cool. If I forget to get it onto the schedule, you'll know what happened. This is a callback to something that happened this month. There was a talk that had been announced with plenty of notice in an orderly way. And I got distracted just about schedule time. So the schedule is day late and dollar short and incomplete and just badly done in its entirety. So later on, we'll be having a break for cake. And you'll notice that it just says break. But there's actual cake involved. In the meantime, Don might have to wander up here a little bit early. Oh, the schedule? Well, SVFIG has a website, and there's also the meeting agenda. This is the meeting agenda, and I do that, and this month it got done. The last entry was made at 5:45 this morning, owing to my inadequacy as a program chair. But the actual Fourth Interest Group website and its daughter or son website, the SVFIG website.
I got HDMI.
Okay, well, it's behind you on the floor, the HDMI cable. If you need adapters, we'll see what we can do. Anyway, that website has been produced over the past, I don't know, is it fair to say 20 years or more? Anyway, it's got content from the dawn of time before there was an internet as such. We used to have coal-fired web browsers in those days. Since it's been modernized, I think it's amusing to note that yeah, there was actually an Amish steam-powered website. It was actually called, I think there's at least one Amish website.
My first impression was that everything is fine.
On the SVFIG website? Yeah. There is an update after every meeting where the meeting notes are updated and the agenda page from that month is copied over. But unless somebody does a project that there's a body of code associated with, there's no code added to it. Dave is the webmaster.
Right, so new this past month is some contributions from Ting's store.
If you stand next to him, they'll hear it out on the internet.
No, that's fine. Ting was good enough to provide some materials from his faked store, which are now on the website.
Thank you very much.
He did all the work. That's it.
Everything's out now.
Okay. Yeah, somebody was asking about that on the fourth IRC channel. What happened to Ting's website? Somebody from a fourth programmer from Iceland was asking about that.
Okay.
Which went away, what, 2 years ago? 3?
This new website has gone to.
Yeah.
Oh, okay. I'm sorry. But 2 things I'd like to say, and that is that if you find like a cobweb or something that doesn't link to something that's actually still in the real world, you familiar with the term cobweb? Some of us older people are much more well acquainted with that stuff. If you find stuff like that, Dave really likes to hear about it. And he'll fix it in the blink of an eye, and I'm always amazed at how responsive he is. It's really annoying in a way that he manages to keep on top of that, where some of us have less organized lives and are less able to actually. I digress. The other thing I wanted to say is that there are soft drinks and 2 sizes of bottled water. Very nice Diet A&W vintage root beer this month. Sam, take note. No high fructose corn syrup at all. Parts per million, maybe. Produced in a facility that produces high fructose corn syrup. I don't know. Trace amounts. But thank you for letting us derail you.
No problem.
So you were able to get up on the screen. We're impressed.
Yeah, Don Golding here. My first bout with Fourth was actually back in 1983. I had a company called Space Tech, and we were developing a computer around the 6502 microprocessor. My brother was a programmer, and he's writing everything in assembler, and it took an hour to compile. and I was rummaging around. I think I saw an ad maybe in Byte, one of the engineering magazines or something, from member LMI Laboratories. Was it Brad? Was it? I forget the guy that ran it, but so that was he sold one called UR Fourth, and it was a professional Fourth system. I just bought it, and I gave it to. We had just hired a second programmer, trying to, we're trying to get the code out much faster. And the second programmer took the UR Fourth, spent a whole week with it, and he reported back to myself and my brother that it wasn't usable. I didn't know, I wasn't a programmer then. I was strictly hardware, and We wound up losing the company shortly thereafter, and I had this copy of "You Are Fourth." Your light went out. Oh, there it goes. Then I built my first computers were actually before. So the first computer I ever, oh, there we go. The very first computer I ever built was called the Cosmac Elf. This is at the Computer History Museum, and I was so happy to find it there. This is the prototype of it. And it used the first CMOS microprocessor ever produced by RCA made it. And I built, now this is back in like 77, so this is before Space Tech. But I built that, and then I was strictly hardware, and I said, I can't even make an LED blink. I can make it blink in hardware. You know, I could design the circuit, but I didn't know anything about programming. So that's when I started taking programming. This is actually after Space Tech. I started taking programming classes. They didn't teach Forth. So what I did is I took Pascal, which is, you know, a very easy language to learn. And I took Pascal programming, and then I took data structures. So you have to take data structures to be a programmer. You can't just learn the language. So with those two things under my belt, I now started learning Forth. I was down at the Orange County Forth group. Will Baden was the one that ran that group. And that's when I started learning Forth. And then along comes about 1989, and I heard tell of a robotics group forming in Orange County. So I go down there, and there's 40 people, and they're going, we're gonna restart a robotics group called the Robotics Society of Southern California, and you know, 40 people in the room. They're all really excited about getting into robots, and I said, okay, this is where I'm going to use Forth, was in developing robots. So I actually became technical vice president of the group. And the president, his name was Jim Burton, and he was a C programmer, and I was a Forth programmer, and we had competition. So we'd develop our robots, and we would compete in like mazes and stuff like that. And my robots, you know, beat his hands down because they were running Forth. But anyway, so that was my first product that I use Forth for development. Now, what's nice about Forth is it's interactive. If you've ever used Logo, Logo was actually written in Forth to be a robotics programming language for the Legos. And you can type, you know, forward 10 feet, stop, enter, and the robot would do exactly that. I developed this robot called Whiskers. So Whiskers, what I was trying to do is I was trying to develop an artificial intelligence operating system so that the robot would be intelligent, would be smart. Everyone in the day, they would program that, they would solve the problem as a programmer and then write code, and then the robot would execute the code. And I said, you know, we gotta get the robots to make the decisions. How do we do that? So at the time, there was no internet. There was DARPANET, and I used to climb on board Interocitor bulletin board in Texas. So I'd go on a 9600 baud modem, and they were mirroring comp.robotics on ARPANET, which is that's actually the internet, but it was called ARPANET back then because it wasn't open to the public. And the top researchers in robotics were talking about this very topic, you know, how do you build an intelligent machine? So you had Hans Moravec and Marvin Minsky. Marvin Minsky's from MIT, Hans Moravec was from Carnegie Mellon, and they built a robot called Shaky. And this robot, pretty good sized robot, and it would go 1 foot, look around the room, create a whole new map, decide where to go next, go another foot or two, and then stop, and then redo the process. So it wasn't a real-time robot. It couldn't do real-time collision avoidance. And they were saying that robotics needed a processor that was running at, what was it, 10, well, like 10 gigahertz. And then there's a there's a fellow named Rodney Brooks who's co-founder of iRobot, and he was at MIT, and he was sitting in his office one day, and he's watching a fly, and flies do collision avoidance really well, and there are only 1,500 neurons in their brains. So they have vision, and they have these very small number of neurons, but boy, can they do collision avoidance. You try to hit one. So he's going, how can a fly do that? And he came up what was called subsumption architecture. And it was a good idea. So basically, you have a task, which is go forward, and then you'd have the next layer up, it would be avoid an object. So each set of sensors would have these layers, and his robot could do collision avoidance really well, but you couldn't give it a goal. You couldn't tell it to go to that door over there. It just would wander around like the Roomba robot. Just wanders around. So I'm reading about these researchers, and I think it seems to me that if you combine those two ideas, then we could have a robot, you can give it a goal, and it would do collision avoidance really well. So I developed, I wanted to develop an intelligent control system. So I developed the Whiskers robot, and it's got four sets of optical sensors, 2 in the front, 2 in the side. It's got 2 whiskers, had a speaker so it could talk, it could sing songs, make different animal sounds. It had a microphone for listening, but back in those days, the processor I was using was a 68HC11, a little 8-bit micro, and it only was 64K of RAM space, of memory space, I should say. So it really didn't have enough power to do any sort of sound recognition, but I did use the microphone to, so the robot could actually hear a sound and go over to it. And then I also I monitored the current in the motors, and so the entire robot actually became a sensor if the wheel got stuck. So I developed, basically I had the outer loop was the goal level, and then I had an interrupt service routine that was running in the background that updated all of these sensors. And then each sensor I had a register, and I had what I called a motor override register. So a side sensor was hit, you could put up to 9 different combinations of motors. So it could pivot in place, it could do, it could pivot about one wheel or the other wheel and then back up and forward. And so basically you put the motor override in whatever sensor you want, and you decide which one you want for the sensor, and then instantly the robot would do collision avoidance. And it also set a flag that has happened, because remember, this is a microprocessor that can only do one thing at a time, so it's asynchronous, not like an FPGA. And so I had that 2 levels of intelligence. And what happens when you have like 2 glasses and the robot comes up, and this instinct wants to go this way and this one wants to go that way, and it would get stuck. So I said, okay, you need to arbitrate that. And so I created the middle level, which I called the behavior level, to where it looked at all the different flags in the sensors, and based on combinations of flags, it would, it could back up, it'd take control from the goal level, and then it would solve the problem, and then the behavior would terminate. So now I created a 3-level intelligent operating system, and it worked really well. So we had games like maze solving. Maze solving was really easy with my robot, and but the robot's making the decisions instead of me, the programmer, making the decision. So that's kind of where we're at today. We're developing a new version, which I'm going to be, I'll make the schematics and everything available once we get it all done. We're going to review the schematics today. This will be the final design review, get everybody's input, and then the next meeting I plan to bring boards. So let's do that. Come on, wake up, computer. So this is the processor. It's an ESP32. I'm using the board version, so we don't have any FCC problems. It does support Wi-Fi and Bluetooth both, and there's no FCC requirements because the board itself comes with all of the RF on it, and it's already been passed. So I did add, per Dr. Ting's request, the USB to serial converter, and I took the circuit from the board, that you're using. So you can just plug in a USB cable and use our Arduino IDE now, and you can create code and download code. Now notice that the converter's using RxD 0 and TXD 0. Those are the two serial ports on the processor. So I was actually thinking, I bring them out to a connector over here, but that chip is going to be, controlling that line. So I'm thinking I can put some board jumpers on there. And so, because I think having the serial port going to that AI board, for example, we should allow the robot to talk to other boards. So I'm thinking put 2 just header jumpers on there, and you put them in for programming, and you take them out, you move them to the next block over, and then now you can talk to the robot over the RS-232. So I'm going to add that. I thought of that today. When I saw the email this morning about that board, that's when I started thinking, we need, because before I had a JTAG, and that was going to be just for I/O. So now, since we're using it for programming, I have to do something about that. So the signals coming to the processor, we have control motor direction, motor number 1, and enable. So pulse width modulation comes out of the enable pin, and then if you go high or low on the direction pin, that makes the motor go high or low. If enable's at 0, then the motor is off. So we have 2 channels. This line here, this is the I LED. So all it's doing is turning on and off and blinking the LEDs. Because when you're doing collision avoidance, you want to the phototransistors go into the ADC channels, and you have to capture the reflectance. So you turn the LED off, and you capture that reflectance value, the amount of light that's on the sensor, and you put it in a register, and then you turn the LED on and you put that in a second register, and then the code will actually subtract the two and put it in a third register, and that's the reflectance value. So if there's nothing there, it'll be a very low number when it subtracts the two. And then there's another register that's your trigger. I call it the trigger register. So it's above that number, then that creates an instantaneous motor override. So we can see that we're using, it says ADC I, 1, 2, 3, and 4 on these pins. So these are all going to ADCs on the chip. CS Mag, we have, one of the things I found really useful in making an intelligent robot is it needs to have a compass. And I created one because I didn't put one on my original robot. I had to create one, and I was counting when the robot, the pulse width modulation of the motors to create like a virtual compass. It wasn't very good, but it actually worked pretty well. But we have a real compass chip on this board, and it's an accelerometer too, so it's going to know when it runs into something, if it hits something. I also put sonar on the board, so we're going to have 2 piezoelectric sonar sensors. One's a transmitter, one's a receiver, and you can see at least 20 feet away with that. So that gives the robot long-range sensing. Okay, so you'll notice that these 2 signals here, these are ADC channels also, and that's the current in the motors. The entire robot is actually a sensor of last resort, because if it gets stuck, the current goes up in the motor, and we can sense that. And on Whiskers, it was really fine. I mean, I could detect when I went up from a hard floor to carpeting. I could actually see the difference. And I expect this to work that well too. We have a speaker, and Dr. Ting has got it singing. So he has all kinds of different effects, and what is it? It plays Bach, I think, doesn't it? Yeah. The birds. Yeah, we have many different sound effects. We have a laser sound, we have a bird sound effect, we have a lot of different sound effects. And what I found is really neat way to go is when you create a behavior, and let's say you're going to have it turn for a period of time, have the sound effect go at the same time it's turning. Use it as the delay, the sound effect. And so it makes the robot seem very lifelike because it's doing multiple things at a time. All right, so TXDO and RxDO, that's a serial port, so that's how you're going to talk to Forth and the robot. These 2 here, this is aux motor 2 and 1. So I had 2 pins available, and what I did was on those 2 pins, we can create a 1 kilohertz pulse width modulator. And now on that single pin, you can actually use airplane servo. So you're going to have 2 airplane servo or something else. I mean, you could put a light on it or whatever. But I was thinking, 2 servos, you could, you might want to have a pan and tilt for the sonar or something like that. So you have 2 servos channels. This is just the switching power supply. The speakers over there. This is a mixed signal design, so we have analog and digital. So I keep the grounds. I have separate analog ground from digital ground, and then I tie them at holy point ground, which is this That's the symbol over here. This, so we have a connector on the robot. It's got all the motor comes off this connector. The two large motors that'll be running the robot around. Some more I/O over there. Let's see. I have a 10-volt circuit here. The robot's going to run off at 12 volts. The 10-volt circuit is you have to ping the sonar sensors with 10 volts. So that's why I'm generating 10 volts. This is the motor control driver. So you have to level translate from, you notice that's 12 volts up here, right? This is 12 volts. That's running the H bridge right there that controls the direction and the pulse width modulation on the motor. And then I just use a 7405, which is an open collector inverter, to do the level translation. And by adding this inverter in here, it allows me to do motor direction. So pulse width modulation comes in here, and you see that's how you get the pulse width modulation. So there's two of these circuits. So these are the two channels for motor driver. Now down here, when you are monitoring the current in the motor, you put a current sense resistor in series with the motor, so that you want the least amount of voltage drop across it, because you don't want to dissipate power in it. So I have an op amp that amplifies the signal. So the ADC, it'll be high enough for the ADC to read it. These are so this is there's the connector on the board for the microphone. This is the microphone amplifier, and that goes into an ADC. This is a really powerful processor, so we could probably do some sort of sound characterization. You know, I don't know. We probably can't do voice.
I read some tutorials for blind people, so they can learn how to echolocate by clicking the tongue. They can sense whether they're near a soft or a hard surface, like a pillow or a brick wall.
You'll be able to experiment with that.
Yeah.
Because we have a speaker and a microphone, so you could ping the speaker. You could actually use the audio system like a sonar, and you could ping the speaker or give it a series of pulses, and you could digitize it, because it's really the same thing as ultrasound, but ultrasound is at 40 kilohertz where we can't hear it. You can do the same thing in the audio range.
Feedback loop on the cord where you get back and then send that out again, and then to the speaker, and then make a feedback loop somehow.
You're going to be able to digitize at a very fast pace, and we have a lot of RAM. You know, I think there's 400 and something K of RAM on the processor. So you're going to be able to take a lot of audio samples, and you could do that kind of experiment. Yeah, and you're basically using it like a sonar. So it's a two-stage amplifier for the microphone, and then you'll see I have the second circuit, which looks exactly the same because it is. And this is the sonar. So both of those signals go into ADCs on the microprocessor, and you could actually, you could actually use the audio system for doing the same sort of thing, because sound, no matter what frequency it is, it's going to be bouncing around.
Yeah, there's actually somebody from Czech Republic who was working on some echolocation with the green rays chip.
Hmm.
We talked on for the previous fourth day.
Yeah, yeah, definitely. Mm-hmm. We can play around with that, for sure. So these are the two drivers for that could be used for the airplane servo motors. So I mean, you make some eyelids or something, or I don't know, whatever you want. You can make a pan and tilt. You could mount the sensors on a pan and tilt, or you could put one sensor on one servo and another on another servo. That would be good for your echolocation. Yeah, because what you could do is you can kind of you could set the microphone where you want it, and you could like spray sound really quickly, and then I don't know, stuff to play around with. Then over here, these are the 4 channels of, you see it says ADC I1. So these are the 4 channels for the optical eyes, which is just an LED. It's a like a 2,000 or 5,000 millicandle LED plus a Darlington phototransistor, and then that's the eyes of the robot. And you can make arrays. I used to do this with the Whiskers board. You can make a PC board with an alternate, like on 1/2-inch spacing, and you can create like an optical sensor that covers a whole area of the robot. So for example, if you make a square base that's 24 inches square, you put these optical arrays in each corner, so like 12 by 12, and now the robot has collision avoidance all around this large base. So you can actually do that with this board too if you want it. And then the last thing is this is the compass accelerometer and inclinometer. It actually has an inclinometer too, so the robot knows if it's on an incline or not. Does anybody have anything on their wish list before we make boards? I think I'm going to add one more connector. So I'll bring out 12 volts, 3.3 volts. I'll bring out the serial port, and then you could plug this connector into, his board, like an AI board or Arduino or any other type of processor, and it could power the processor plus allow it to talk over RS-232. Because we're going to have so much intelligence on the board, you don't need a high bandwidth interface. You're going to be given it very high level commands. Your AI module, is going to be telling the robot, hold this compass heading, very high level commands. So we don't need a high speed interface. RS-232 will be fine. And when I was working with Whiskers, it was fine. I was running at 9600 baud, and it was fine. I even, my military robots use the same board, and I created a high power driver board where I could drive big motors. And I was doing real time joystick control, and it was fine. And 9600 baud. Oh, that was 19.2, actually. That was 19.2. It's using some military RF radios. So.
Add other peripherals, also, other sensors.
Well, I think you would basically just network them. This won't be the last board. We can get started with this one, and I could create one for bigger robot to make bigger machines if we want. if we make it too complicated, you know, this is kind of an entry level. Yeah, it's a good start. It doesn't cost that much to make PC boards anymore. So, you know, get everybody, you know, started with developing code and learning the 3-level architecture. And this will be a great board for that. And you can plug in really powerful boards using this new connector I'm going to add. Dr. Ting's ePort.
Yes, the battery.
12 volts.
12 volts.
And the motors will be 12 volts.
So you have the 12 volts, and then it's power supply lower to 5 and 3.3.
Yeah, it has a switching power supply. I only have 3.3. I don't think we need 5.
Okay, the chip is 3.3.
Mm-hmm.
Okay.
So, yeah, when you're designing a new board, you start thinking, oh, I could just add that, you know. And I was actually thinking about that coming up here today, and I go, you know what? Let's keep it simple, because I thought I could put a little FPGA. No, let's just keep this board simple, and this will get everybody, you know, up to speed on robotics and robotic control, and then we can say, okay, we want to build Johnny 5, you know, next year. So then we can, and that's where you want to have networks of processors. So anybody have any comments or suggestions before we spin the board?
Can I use, I guess I could operate the fourth prompt remotely over a radio, perhaps? I guess it's RS-232 radio.
Yeah, it's so easy. You know, you get any of these little wireless boards and you just plug, you know, RX and TX into it, and you're done. Right. And you have a wireless RS-232 link. But remember, this has wireless Wi-Fi and has wireless Bluetooth built in. So there's actually 3 ways to get wireless. 2 supported directly, and 1 you just buy, you know, they're probably $20 or $30 board sets for RS-232 wireless.
I tried low-rod radio. The networks are really far away.
Were you setting up STI or to see how base?
Well, we're actually using every I/O pin on this processor, but I did bring out, let's see. So, all right, so I'm bringing out, I got 1 GPIO line there. So RTS and DTR are part of the programming interface. I could bring those. What? Oh, I forgot to tell you. There's an SD card on it. I forgot to. Yeah. So the robot could have gigabytes worth of memory, of long-term memory. So one of you guys will have to write the OS for it. So I know it's out there. You know, it's already written in C. You can download it. And or you know, I don't know. Do we put 4th blocks on it? I don't know. Huh? No. Okay. All right. Well, anyway, one of you guys, because that's really not in my department. We need to figure out what formatting we have to do. You know, maybe just format it in DOS or something. You know, and
That's the easy way. Just do it fast.
just do it what?
Do fast.
Okay.
They have their own, I think the newer SD cards, if I remember correctly, have their own wear leveling built in underneath.
Mm-hmm.
So you don't need to handle that yourself.
That's right.
So you can just use the SD card blocks. Those are, I think, size blocker that you can have. Instead of the original SD cards with byte address, the new ones are block addressed. So SD HC cards, and you can onward are block address. You can just use the block editor on those, perhaps.
I think this one is the SPI, right? So the SPI interface, flash interface.
Oh, that's true. Yeah. Should I bring the flash lines to a connector then, and you could use it if you don't plug in an SD card, you could use that as your SPI interface because that is the SPI for the processor. All right, so I'll add a connector for that, and then that'll give you SPI. All right. Anybody else want to buy 2 boards? Okay, so they're $50. Kevin's bought 2/5 of a board. That's what that $30 is about. He's on the easy payment plan. Well, I'm going to bring a saw and I'm going to cut off a little piece of a board for your $20.
I don't have $50 with me right now, so.
Next month is fine. Yeah, no problem. All right. Any other questions? All right. We'll get the boards made. So I'm going to add. I'll add a couple connectors. Give us a little more flexibility.
So if you want to give me the mic, I've got a couple of things I want to say.
Okay.
So, I wanted to say that in addition to being the Apollo anniversary, it's also the anniversary of Twilight Zone. I recommend to you Gilbert Gottfried's amazing Colossal podcast, where he talks to a panel of folks about Twilight Zone, and that should be interesting to watch or listen to. We were talking about the Behemoth bicycle on the Microship website. There are links to a couple of YouTube videos of talks about that. So I recommend that to you. And there was one more I wanted to show that was actually relevant. I heard UR4 mentioned from LMI, Laboratory Microsystems Incorporated. Ray Duncan is the guy that you were trying to think of. And by an odd coincidence, Ray Duncan sent us some papers from his personal collection. And a little later, we will actually open the boxes and see what's inside. And maybe Dennis can pan down so that we can see Andreas actually waving this stuff around in front of you. One-of-a-kind things will be scanned in, as long as they're not somebody's intellectual property or otherwise at issue. made available either on the website or otherwise. So join us a little later in this same stream for that. If you, I don't know that anybody's going to be terribly interested in reading this short blurb, but I might actually send a link to it to the mailing list. So I think that if everybody's ready for a short break, we'll see if Dave can be persuaded to get out his cake, and we'll eat it too.
Testing, 1, 2, 3. Hopefully people can hear me. My name is Sam Falvo. I'm normally part of the Kestrel computer project or have something Kestrel related to present, but today, not so much. I spend most of my time at the office doing professional things now, and not so much time at home working on Kestrel things. So approximately the first week of this month, I was actually had one day that I was like, you know what, I'm going to learn some Smalltalk. So I downloaded and installed Squeak Smalltalk, latest version, 5.2 or 5.3 or something like that. And actually had probably for the first time since I've tried, a reasonably good experience exploring the environment, having trying to write software that it is an attempt to port a video game that I wrote a long time ago called Equilibrium from GeForce to Squeak Smalltalk. And I figured graphical environment unto itself, I don't have to worry about graphics libraries or anything like that. Whereas in GeForce, you have to A, make sure you have a compatible copy of GeForce, and B, make sure you've got a compatible copy of SDL. So you've got two levels of dependencies to work with. I kind of grew to like the environment. But part of me really wanted to continue using Forth for a variety of reasons. One is, even though I could learn to navigate the code in Smalltalk fairly easily, there were pieces of the Smalltalk environment that I just could not wrap my head around, like which I'll probably get to and show you here in a bit. In fact, let me give you a quick demo. If I can somehow arrange this. So what you're seeing here is a Smalltalk 80 environment. It is currently it is what you would call a live programming environment. So these windows, for example, these are objects in the object-oriented universe that it has in its image file. And as you can see here, whoa, come here, behave. This particular window here has a bunch of notes that I wrote to myself about how to work with morphs, which actually is what these things are. Basically, anything on the screen nowadays is a morph. The old model view controller system is almost never used anymore. But let me show you some of the aspects of the Smalltalk environment. Let's say I want to know what this particular class is defined as. So I can highlight that, pull up a menu, and somewhere around here. So you debug it, There we go, browse it. So what you can do is you can pull up what's called a browser. And this is a constrained browser. As you can see here, it only lists the relevant classes that go all the way up to the most basic of the base classes. This is the template that defines the morph as Equilibrium game. Morph is its superclass. These things here are all of its member variables and so on and so forth. I won't get too much into this. You can classify methods. This is something that I really like, and I wish a native Forth environment had. Comments in a text file just don't cut it. This is actually a lot nicer way of organizing things. And basically, each of these chunks of code here, if it doesn't have the source code available in a file, it will decompile Smalltalk bytecode, and you can actually edit the Smalltalk bytecode directly as though it were actual Smalltalk source code. So, and you know, you can go and you can browse other parts of the. Here we go. You can browse other parts of the system classes as well. And you'll notice that there's a naming convention here. Basically, you have like a library dash and then a specific thing. So the collections library, so to speak, here all starts from here, you know, and continues on all the way down here. Basically, these are specific. These are categories of classes. These are the actual classes over here in the second column, which you can see here by their templates. And then, of course, over here, you've got your usual method drill down as well. Right? So, and it's not just application stuff that sits in here. As you can see here, there's kernel classes, for example. And look at that. You can actually edit what classes mean by editing the class. So if you can wrap your head around that, it's very meta, very much like Lisp and Forth. Smalltalk is a deeply reflective and dynamic environment that it actually encourages you to modify to meet your specific application's needs. And if you really wanted to, and you wanted to mess someone up, you could swap the meaning of true and false, and it will happily obey your commands. But I won't go into all of that detail. But what I will say is, I'd like you to take a notice. For instance, when I resize this window, notice how it's responsive, right? So I spent some time trying to figure out how that worked. And the reason I wanted to do that is let me attempt to do something here. Okay, so I've just created a morph that is basically this black playfield thing with a white rectangle. And I can move it around, and as you can see, the white rectangle moves along with it. Now, if I resize this particular morph, you'll notice that it appears to chop off the edge of that smaller morph. But in reality, it doesn't. So my question is, how do I get this dynamic behavior over here to work with my own particular morphs? I won't show you the long and perilous journey that I used to arrive at the conclusion that I can't. Surely there must be a way for me to do it, but I have not figured out how yet. And part of the reason is when you have a code browser that allows you to poke your nose into all manner of system classes, and you have a runtime environment that depends heavily on polymorphism, you run into a lot of these dead ends. And the only way to really debug or figure out what's going on is to instantiate an instance of this class, create a test scenario that replicates the problem situation that you're facing, stick a self-halt command into the source code, run that code, and then single step through the code, which in my opinion kind of defeats the whole purpose of having a reflective environment like this. So I was kind of thinking to myself, you know, one of the nice advantages of Forth is that you can look at the source code and lexically determine exactly what it's going to do, how it's going to do it, who's responsible for doing it, and all these other nice attributes that come with an early bound language. And so it got me thinking, how do I arrange how do I get to a runtime environment like this where, you know, I can say, oh shoot, you know what, my code just crashed, I need to fix it. So let me go in here, let me change this. Okay, now I'm going to commit that. I'm going to restart the method and then proceed. Okay, so now I'm able to fix that particular bug. Oh, but you know what? There's this other bug here. Well, shucky darn, right? This is kind of the problem that I was alluding to earlier, right? So here's another manifestation of the problem that I was having. So how do I get this to be responsive? So I never could figure it out. So what I'm going to do is basically come up with a daydream, if you will, something that I would like to necessarily committed to any of these, but pairing some systems that I know about that already exist, that I've actually personally worked with. Obviously, Smalltalk, it's an image-based environment. What that basically means is this whole environment here is running in one giant virtual machine. This is basically it's fundamentally not any different than running in a Commodore 64 emulator. I can actually quit this. I won't save my changes, but if I do come back here and I restart, right, the machine comes right back up. Or if I do save my changes, it'll come back up in the state that I just left it. Flip the lid down, it saves state, same idea. It's on small Earth programmer, that's gargantuan. But you got to remember that that 60 megabyte image includes source code that was developed by Alan Kay, Dr. Kay, and his Smalltalk researchers, dating all the way back to 1976. So when you consider that the language has been around for about 40-ish, you know, estimated 40 years, that's actually not that bad of an accretion rate. Colorforth, of course, is also an image-based system, whereby when you launch Colorforth, it loads an entire chunk of binary data off your storage medium and then runs entirely from memory. But it tends to be a lot smaller, in part because it's newer, but also because it's very task optimized, as Smalltalk knows it. Both systems, as you can see, are quite fast and agile. You have to learn its peculiarities first. But simple in design is just the opposite. Colorforth is very simple if you were to look at it as from an architectural point of view. And Smalltalk, not so much. It needs a whole book to describe it. So it's kind of, and I do recommend reading the Blue Book, by the way. It is actually quite enlightening. See here, they both have their own particular sets of innovation. Live coding and debugging in the case of Smalltalk, it was one of the first systems other than Lisp to be able to do that. And in the case of Colorforth, a compiler that is probably faster than most operating systems can load raw binary code, and persistent variables, by which I mean the storage for variables are actually embedded in the source code rather than in the dictionary proper. So you can freely change the source code around, and as long as you don't delete or introduce new variables, the state of the program that you're editing remains intact. So this is kind of, I bring this up in particular because remember I'm talking about the whole live coding convenience aspect. And that actually goes, even though Colorforth is not a live coding environment, it feels like it is. And probably one of the best things that I've had the pleasure of observing was Chuck Moore and Jeff Fox, both using Colorforth and flipping between editor, application, editor, different application, editor, you know, and it's like it looked as though all these programs were running all at the same time, when in fact they were not. They were actually running sequentially, one after another. But it was so lightning fast and so fluid, and they preserved state in between invocations. From a practical perspective, it was indistinguishable from a live coding environment. So that was kind of a experience. And then, you know, the rest of this stuff I'll put into a slide deck later on. But that's really the one of the cruxes that I wanted to compare. But if you look at G-forth, which is what equilibrium was originally written in, the answer is either no, no, not bad, not at first, no, no. You know, like it's very, very optimized for running as a scripting engine under a operating system environment. So yeah, technically, I mean, it's the difference between Squeak Smalltalk and GNU Smalltalk, for example. GNU Smalltalk is technically Smalltalk, but you don't really run it with a user interface. You don't really run applications. It's designed to run scripts, and then that's it. So that was one of my demonstrations of Squeak. I'd like to discuss some prior art ideas. Obviously, the first thing that comes to my mind, again, because I have some experience working with it, is the Cozy environment. This is kind of neat because Cozy is largely inspired by APL, which in turn really informs a lot of the architecture of how it was built. APL itself was an image-based environment as well, but it was more command line oriented back in the mainframe days. And what Cozy did was provide a basic kind of GUI wrapper around it. So it's still an image-based system. You're still really running only one program at a time with it. But if you're clever enough with how you write software or how you invoke it, it can still feel as though you've got a multiple general purpose environment. And for a long time now, I've been wanting to port aspects of, or even the entire environment of Cozy to the Kestrel 3, because I really liked how you can do vector programming very easily with it. I think that it is a good fit for the fourth environment, and I'd like to exploit that in the future. I think that what it brings to fairly simple dynamic memory management built around vectors of things. And you don't really need a full GC because there's an invariant in the system that is no cycle exists between entities. So in that sense, it's very much like Python 1.4. Necessarily incompatible with garbage collection. So if later on you really need the expressive power of garbage collection, but it's just that it's not needed. And so there's no real motivation to implement it. The smallest unit of development. Now, this is something that I haven't really discussed yet. In the case of Smalltalk, it should be fairly simple that the smallest unit is the method. You make a change to a method, you hit Control S or click accept, and as soon as your finger lifts off the mouse or off the keyboard, that chunk of code is already compiled and possibly already running. And to give you an illustration of that, I will come back here and I will browse this particular class. So let me, oops, I forgot. I probably should have saved, but. So blah, blah, blah. I do my edits. I commit. It's already compiled. So I restart. I proceed. Program is running. Okay. But you know what? I later on realized, shucks, I don't need the scoreboard as a distinct variable because it's already kept as a child of this thing. So I really don't need that. I only need the playfield, so I can save that. Oh, that's weird. Why did that bring up a browser? Oh, okay. Well, whatever. Let me, whoa! Yeah. So as you can see, you need to be careful when you're working with data in dynamic environments because it's very easy to break things. And like I said, Smalltalk will let you define false as true and true as false if you ask it nicely enough. But that should give you an illustration, right? So I just make a few. I've got world-affecting behavioral changes, right? Really happen in ColorForth. In ColorForth, your smallest unit of change is the overlay. Now you would think that it would be the block, but that's not really the case because in order to load the block, you have to load its surrounding context as well. And in order to do that without running out of memory, you have to run empty. So you're basically swapping out entire swaths of the dictionary. Granted, they're very small swaths, but nonetheless, entire chunks of memory that typically start at a particular address in the dictionary. And so you tend to work with overlays more than you do with individual methods. But again, the user interface model of ColorForth is such that it feels like you're working with individual colon definition, but you're not. You're actually working with entire programs, or at least components of it. Oberon system is another historically important self-contained system. Let me bail from here. I will not save my changes. So this is Oberon system. And I know you can't really see it, at least on the YouTube stream. I apologize, but that's the size of the font that we get, and that's all that we get. But one of the things that you can do, this is also a consistent environment. And what I'm going to do now is I'm going to run a program called stars. And as we can see, it bounces a bunch of stars around on the screen, right? Not a big deal. But you know what? It's moving a little bit too fast for me. So what I would like to do is I would like to change this program. So what I'll do is I'll highlight the name of the module that I've written down elsewhere. I will now open, oops, let me tell it to go over here. I will now open the source code. And I'm now going to introduce another 0 there in the interval. I'm going to save that. Now what I'm going to do, oops, you know what? I forgot to close this out. So I need to close out the running program. I'm now going to tell the system to unload the previous version of the program. Re-highlight this. Oops. You know what? It'd be easier if I just did it over here. Stars.mod. So I'll recompile it. And so now theoretically, I should be able to, yeah. So yes, this is another environment that you can work in entirely consistently and logically. Anyone who can see this font will recognize it as a Pascal-derived language. It's actually Pascal's great-grandchild. But notice how much machination that I had to go through. Like I had to manually manage modules. It'll happily load modules for you on your behalf, which we can see if I were to, for instance, execute this. So here you can see the bunch of compiler modules. There's our stars module here, and all the other operating system that comes with it, and so on and so forth. But you have to manually manage them because if you make a change to a module while the system is still running, you can actually really confuse the system. It'll happily load the new module, but then when it goes to link your binary, it links it against the old version of the module. And then you're stuck because now you can't unload you can't ever unload the old version of the module. You actually have to exit the system and restart it. So that is an interesting artifact of how Oberon system works. This is a nice system to work in. I actually recommend people learning this as well. A lot of good ideas in this environment, but again, doesn't really pack the convenience of Forth. So what I'm looking for is a system, or I should say what I'm really dreaming about. Let me move that back up to the top. What I'm looking for is something that is built around Forth and Forth's properties. And what I'm thinking of, all these systems, they all have they're all built around a logical thing. So in the case of Smalltalk, it would be objects and methods. In the case of Oberon, it would be modules. I'm thinking that for Forth, the active element here should be the actor, what's called an actor. And in this sense, it probably bears some resemblance to Erlang. It should be, I would want something that is image-based, emulator over, and basically I want something that is that really takes advantage of actors, especially since green arrays and array, I'm sorry, not array Forth, but green arrays and the C-Forth and so on. Like there's a history of using communicating sequential processes with the Forth environment. And I think that should be exploited. So let's see here, I got my list of stuff here. The idea is one actor equals one dictionary, one message queue, and then a minimum of one coroutine to drive it. Now, the reason for this particular thing is a dictionary is very statically allocated, right? So you start with the base Forth definitions, you build on top of that using hyperstatic global software construction. But if you have multiple different actors, obviously they're all going to be different size dictionaries. They're all going to have needs, environmentally speaking, and so forth. Not everyone is going to have a dependency on the same chunks of code. So what I'm thinking is each individual actor has its own dictionary, which is dynamically allocated, perhaps even using COSI style vectors. And to help coordinate all of this, I would like to use something along the lines of like the Tripos kernel. Tripos is the foundation of Amiga-DOS, and so anyone who's used Amiga-DOS will have a feel for how it handles multitasking. It is a preemptively multitasking environment with dynamic memory management, so it would fit the bill here perfectly, but it is built for single user environment. Now, I'm not specifically saying that we should port the entire CLI environment or the file systems or anything like that. I'm talking just the kernel. Coroutines, of course, in case you need what's called a multi-evented software architecture. That should always be an option. And coroutines are just nice to have for other reasons as well. And it's easy to port. Tripos is about 30 kernel functions. That's about it. It's about the same level of complexity as a Forth environment. Which is awfully convenient. And then there's also 30 standard library functions as well, which sits outside of, but that is, again, fairly well within the realm of easy portability.
Instead of having multiple dictionaries for each actor, having a dictionary for each actor, why not use just have one latest pointer for each actor and then using the same dictionary address space so that it would interleave the dictionary, the definitions in the dictionary, and it looks like multiple dictionaries. Why not just do that?
So why not interleave multiple programs in? So the biggest reason why I don't want that is if I'm developing something and I add empty to free up the dictionary, I don't want it to have to kill 15 other processes in the process.
You don't want to wipe out all the other actors?
Correct. All the other actors should remain logically independent as long as there's no dependencies between them. So that's the motivating factor. Otherwise, yeah, that would work well. And the other thing about TriPOS is historically it's been written in BCPL and assembly language, but it's actually quite easy to rewrite in Forth. Some people might remember my STS operating system for the original Kestrel 2 and later also the Kestrel 2DX. That is a small subset of TriPOS's kernel that I ported to a Forth-like environment, and it runs just fine. So the dictionaries, like I said, are contiguously allocated. That is basically a requirement for Forth 2K compatibility. If we wanted to break with Forth 2K compatibility, then I'm sure we could possibly do something a little bit more dynamic, but I'm not sure how I would pull that off. And then each dictionary is programmed in whatever way it makes sense, which actually kind of alludes to what the question that you asked, right? So if a graphics actor is going to have probably a large dictionary because it's going to have a lot of graphics primitives programmed into it, going to have any dependency graphic stuff. So if I wanted to kill the game of life and word processor or something like that, I could do that without having to affect the screen display. Which brings me to basically the UI stuff. If you do manage to change the source code of the UI itself, whether it be the screen driver or the graphics libraries, you also don't want that to affect the running programs that are currently running. And as my bug showed, like there are limitations, right? So if I'm affecting the code, I should not want to affect the state that the code is operating on, if that makes sense. So for instance, if I wanted to change the layout of this toolbar, for instance, I should be able to do that in code without affecting the database structures in memory that allow these to work in the first place. If that is necessary to be done, you have to be intelligent about it, right? You have to come out with a schema evolution of sorts. You have to make your change in a backward compatible way, update all the code to use the new way, and then you can remove all the old legacy stuff. Otherwise, you end up with, well, I killed it. Otherwise, you end up with that small talk image with all the dialogues. What's up?
So you're using hyperstatic scoping for that to achieve that, or?
So each dictionary is hyperstatically scoped. Yeah. And then, lastly, as I indicated, I wanted the image to basically run as bytecode. And some years ago, I received permission from Dr. Ting to work with the EP64, a 64-bit variant of the EP architecture. I never did get that to work in silicon or on an FPGA. I actually do have Verilog, which runs, but I never actually proved it on silicon. But I'm thinking this would be a good application for just a generic bytecode. So instead of having it run on actual hardware, just have a bytecode interpreter, just like Smalltalk did back in the day, and as Oberon does today. Basically, just emulate the virtual processor, and then that way the compiler is simplified for that. All your peripherals are simplified. Everything runs inside this virtual environment, which then is portable by virtue of this image file between x86 machines or the Kestrel 3, which runs RISC-V. Earlier today, there's some discussion about neural network microcontrollers and stuff. If you wanted to apply to an embedded environment that has this I think it's the SVFIG RISC-V processors that they're talking about, conceptually it should be portable to that as well, right? So, and the only way to really do that is to use a processor agnostic representation for both code and data, and that's what the image file represents. So that's kind of where I'm at. I'm actually exactly 30 minutes at this point. So like I said, this is just kind of off the back, the back of the napkin daydreaming of some stuff, some attributes that I've been thinking about. Act on some of this, especially in the context of the Kestrel coming up in the next couple of years. And we'll see where this goes. Cool. Any questions? Yes. I've heard the comment was reminds him of Hole on Fourth, small talk inspired Fourth. I've heard the name. I remember reading some stuff about it many years ago, but I really don't have any familiarity with it. Someone else had mentioned, I forget exactly who, but there was another small talk inspired Fourth, which actually allowed for hot coding as well, small talk style hot coding. And apparently it was a topic that was discussed in one of the journals. I think it's JFAR, but I'm not sure. But unfortunately, I could not find any evidence on the internet that it actually existed per se. So there's no way for me to run it or even examine the source code. So if anybody knows about that, I'd be happy to learn about that as well. Cool.
Hello? Are you ready? So this, right. These are from, this is the unboxing video for, so Ray Duncan sent these. Ray Duncan sent these Fourth materials, literature. It's we don't know what's inside yet, or at least for the purposes of this video, we don't know what's inside yet. Fourth stuff, yeah. So here's a box cutter. I'm going to untape it. Good packaging. The tape is very well secured, securing the box. It's the packaging is very nice. Has a nice, pops right open the box. Just it's very sturdy, this box. It's good. It's like just it's a bit of a tease when you open. You pull the. Okay, so now it's open and there's bubble foil. You can pop them. Got kind of fun. You can pop the bubble foil packaging, and inside there's a fifth 2.0 reference manual. I've never seen this before, and this looks interesting. It has text editor, all sorts of stuff in here. I've never seen this before. Fifth 2.0 reference manual by Cliff Click and Paul Snow. And here's a PDP 11 fourth user's guide by John S. James. Pretty interesting, yeah. And a programmer's handbook, Elizabeth Rather. And Mastering Fourth, this is a good one. I have this. It's kind of like it goes well together with this other book, Starting Fourth and Thinking Fourth. And there's another one. I think I have another edition of Mastering Fourth as well. Here's Thinking Fourth. Very good book. One of the best fourth books. And Starting Fourth. Yep. Second edition, yeah. And just the paperback, yeah. And here's a hard copy of Fourth, a text and reference, hardcover copy. This looks like MMS Fourth by I think he lives in Massachusetts. And here's a copy of a hard copy of Stack Computers, The New Wave, with a hardcover. Yeah, I need to read this one. I should read this at some point. Yeah, and I haven't read it yet. It's been on my list. So yeah, that's what's in the first box, and here's the second box. Untaping it. Yeah. Don't cut the books. Yeah. Forget my fingers. Don't cut the books. Yeah. And here's the next box. If anyone wants to look at these, you can flip through them. This looks like a binder that contains stuff about VAX Fourth 32, Fourth System, Angelica Fleisch. Yeah. Yeah, it wouldn't be a VAX product. He said it wouldn't be a VAX product if it didn't have a binder for documentation. Yeah. This looks interesting, yeah, to read that. And next is a book without a binding. Actually, yeah, without a binding, but stapled together. It's Fig Fourth for 18,802 assembly source code listing. And stuck to it is a Fig Fourth 80, 86, 80, 88 assembly source code listing. And next is Fourth Max User Guide by Bradley Fourth Ware. Mitch Bradley, yeah. Yeah, I think does he live in Australia now? I think so. I don't know. No? I thought he did. I think he was on the Embedded FM podcast at some point, and I think he lives in Australia, but I might be wrong. And here is the 6809 Fig Fourth assembly source code listing. Release 1 with compiler security and variable length names. And below it is FIG 4 through PDP 11, assembly source code listing. And then we have Sun 4th Users Guide, Mitch Bradley and Michael Sari. Revision Sun D. And then we have 4th 83 Standard, publication of the 4th Standards team. And here we have American National Standard for Information Systems, Programming Languages 4th. So Anne's 4th Standard. What was that? Printed standard, yeah. Never seen a real printed official standard of 4th, yeah. You remember Don was a member of ANS standards. You weren't. You were. You. Dennis was a member. Yeah. For a while. Yeah.
I never saw printed.
And this is C4th 83 glossary. Mitch Bradley 4th wear. Revision A. And what's in here?
What I meant was Ray Duncan was modeled.
Oh, Ray Duncan.
Ray was on the
ANS, yeah. New words for 4th Max, version 1.1. This looks like this cover. It has 4th Max by Bradley 4th wear.
4th Max was 4th under Unix running Emacs.
Ah, 4th under Unix running Emacs, as Kevin said.
So you edit the source code with Emacs to compile it. Right.
Yeah. All right, that's all. Treasure box, treasure chest.
blocks and files.
Blocks and files.
Forever debating.
Two's complement versus one's complement.
Two's complements versus one's complement.
Those were the days. Division.
Yeah, division was always the stickiest stuff.
And the 31 character names.
31 character names. Just about everything was debated.
All right.
Just about the Mitch Bradley. I think Kevin gave me a link from C4. He actually rewrote this. I mean, for the C4 to ESP32.
Yep.
So that was very nice.
Yeah.
But I tried to read the code, and yeah, the C4, and then the Walbaden's this force.
Right.
And yeah, this force and C4, they're both fourth within C.
Right.
And
so is Pickle.
And they're very difficult.
Well, this fork was sort of forthwritten in M4.
Yes,
Yeah,
it is.
It wasn't really C. It was M4.
Wait, like M4 macros?
Yeah.
Like what Auto Tools uses?
Yeah.
Oh.
Yeah.
Oh.
It's very difficult. There are lots of files. And
All of them are, for some reason.
So I just feel that my recent information of the bread that's the best one.
Well,
It's just in one file.
they're all 1/4. And especially in the C4s. Everyone's different. Everyone's unique. They're all doing the same thing. But
Never the fourth thing. You've seen one fourth,
fourth,
you've
you
seen
see
one
one
fourth.
fourth, especially with C4s.
And another thing is the fourth, the C4 that John wrote. Big John.
John Harper?
Yeah, John Harper. And and it turns out I didn't read his code carefully until a couple of weeks ago.
So you missed the end user license agreement.
You guys remember Ventil?
And then
I have that
saw
source
that
code.
I was thinking very much like him thinking. So although I didn't copy his ideas, but it turns out that they're the same. So we just let me see what he did. Okay, one thing he did very nicely was that he used the union. He used the union concept to describe the same dictionary in integer as in character. Okay.
Ah,
Yeah. So it's the same big array, but you have two views. You can view it in integers, and you can view it in character.
so does it mean you can port it between byte-oriented machines and word-oriented, cell-oriented?
Basically, byte-oriented machines. But you have two views. You can access the entire dictionary in bytes or in integers.
That's cool.
Yeah, so that's the same thing. I was using a mechanism I really didn't understand. It's just I declare an integer array, and I then declare a pointer, a character pointer, pointing to that array. And then I can access the array both either in integer or in character. So using union is much cleaner. So he actually in his code he generated the dictionary, a separate dictionary, and then compiled that dictionary in the next step. Yeah. So that was the standard way of doing things, and but I did it in one step. Instead of compiling it, I was at runtime generated the dictionary.
Yeah.
And
Well,
that's easier.
Max was more regular fourth, a native fourth, with a C wrapper around it, so
Yes,
that it
that-
could access the file system and terminal I/O and things of that sort.
That's the C4.
Well, it isn't written, the fourth isn't written in C. The wrapper is written in C. The fourth is written in fourth, just like plain old fourth.
Well, you are right. Many files are four files, but the kernel is in C.
Maybe you got a different version of FortMax from the one I'm talking about.
Well, that's the one. That's the latest one
Well-
on the ESP32.
No, that's not FortMax though.
No, not FortMax. Yeah, it's the
That's
C4.
C4. I'm saying that FortMax wasn't fourth in C, it was fourth in fourth. With a C wrapper so that it could live on a Unix system without much pain and anguish.
All right.
All of them are just another fourth.
Okay.
Okay.
All right.
Okay.
Thank you.
Thanks, Ray Duncan. Thank you. Thanks for this treasure chest.
What was his purpose?
What was his purpose for sending?
Just cleaning house?
I think it's just like everybody else. I'm not getting too old.
Well, that was the first thought.
All this time, like, the boxes are in. every time you move.
Yeah.
Okay, tell everybody we'll be next month.
We'll see you next month. Stay tuned for next month. Yeah. Oh, microphone.